This is the solution video for section 7.3, problem number 12. All right, so the integral from 3 to 2 of x squared minus 1 over x minus 1. All right, so first of all, we need to integrate by reducing that fraction. So we recognize that x squared minus 1 can be factored into x minus 1 times x plus 1. And if it's divided by x minus 1, then you can see that the x minus 1s would reduce. So we reduce this, all right, and now we have the integral from 3 to 2 of just x plus 1. Now, it's important to note that this function, the original function, would be undefined at x equals 1. And so that would be problematic if our interval included x equals 1, but it does not. So that is not a concern. All right, now we have the integral from 3 to 2. So don't worry that these are, like kind of out of order because 2 is less than 3. It will work out when we actually plug in. So the integral of x plus 1. So we're going to integrate separately. So I get x squared over 2 plus the integral of the integral of 1 is x. And so now I have x squared over 2 plus x evaluated from 3 to 2. All right, so now remember, the top number goes in first. So I have 2 squared over 2 plus 2 minus, now the bottom number, 3 squared over 2 plus 3. It doesn't really matter that the bottom number is bigger. It matters that you put them in the correct order. All right, so 2 squared, 4 over 2 is 2, plus 2 is 4, minus 3 squared, 9 over 2, 9 halves, plus 3. So plus 3 would be like 6 halves. All right, so 9 halves plus 6 halves is 15 halves. All right, so 4, which would be 8 halves, minus 15 halves is negative 7 halves. All right, so now you want to realize that if I'm going from 3 to 2, all right, let's think about the graph. X squared minus 1 over x minus 1 when we reduce is x plus 1. So it actually behaves just like a line, except it happens to have a hole at x equals positive 1. But I'm looking for the area from, well, 3 to 2, right? So this area, yes, would be positive if I was going from 2 to 3, but I'm actually going from 3 to 2, so that's why that area is negative.